When doing the limiting and excess, the only way to get them is to practice, and obviously a lot of you guys put in some practice. I want to congratulate you. This is the first year that I have gone where I haven't had to hammer this point because nobody made this mistake. Compare reactants. So when you're doing limiting and excess, when you're just figuring out which is limiting, which is excess, you should never have any of the products in any of your factor labels. You're only comparing reactants. So and nobody did that. Nobody made that mistake this year. Awesome. Mole ratio, reactant to reactant. And, remember to write your sentence. So you guys did fantastically. And those of you who are a little bit rough on it, come see me and we'll do some more work. If a recipe calls for 2 dozen cookies, do you always get 2 dozen cookies out of it? Anybody here a dough eater? Yeah, not supposed to eat dough, but oh well, it's delicious. So we don't always get the full amount of what we're making out of the recipe. So we might only get, well, if you're having a really especially bad day, maybe you get a dozen cookies. Oops, a lot of dough eating, a lot of maybe accidents, maybe you dropped some on the floor. Who knows what goes on in the kitchen? We don't ask. What percent of the cookies you were supposed to get did you get? 50%. Okay, so this is what you were supposed to get. This is what you actually got. You got 50% of the cookies you should have. That is your percent yield. So percent yield is simply what you actually got divided by what you should have gotten. Okay, actually got divided by should have times 100, of course. Okay, so in this case, you got 50% yield. So let's talk about it in slightly more technical terms now. Percent yield. Theoretical yield is what you should have gotten. So what you were supposed to get is your theoretical yield. What you actually got is your actual yield. So the theoretical yield is the maximum amount that can be produced from a reaction. It's the maximum amount of product you can create. And for a lot of reasons, now in a chemical equation it's not quite like making cookies, we don't have people eating the dough, but things happen. Reactions don't run fully, or you don't recover all the product. If you've ever made a cake and not scraped the bowl especially well, not gotten all the batter down into the pan to bake, that's loss. That's a source of loss. And that happens in chemical reactions. You've seen reactions where you left a lot of stuff in a flask. And, so often, oh, no, okay, it does say often, I just covered up part of it. And so actual yield is very often not the same as your theoretical. Using these two pieces of information, actual yield and theoretical yield, you find percent yield. It's the percentage that you got compared to what you should have. So if we take the following reaction. Okay, so using this equation, we're taking magnesium oxide and aluminum, we're getting them to trade places in a single replacement reaction, and we're forming just metallic magnesium and aluminum oxide. Wonderful. If you do all your calculations and you figure out that you should be able to produce 150 grams of magnesium, but you run the reaction and you only get 146 grams of magnesium, what's your percent yield? Well, we remember this equation. Percent yield equals actual over theoretical times 100. So this is pretty easy. Plug your numbers in, 146.0 grams of magnesium over 150.0 grams of magnesium times 100. It's 97.3 repeating. With sig figs, we would have 4 sig figs, so we would call it 97.3%. 97% yield isn't bad. If you're in a quantitative analysis class, you have to be at 99 or above, but this is not bad. If you guys got a 97% yield in a lab here, I'd be pretty impressed. That's pretty good for basic lab technique. Okay, now, how often do you figure you get a problem that's that easy? Here's your theoretical. Here's your actual. Just set it up and go. It's not typically how we do it. So you understand the concept of calculating percent yield. Now let's look at how this is more commonly done. So let's say we're working with this equation again, and we're told that we have, or we are given, I should say. So we state that we're given 265 grams of aluminum. This is all the information we get. And we're told that we produced 328.9 grams of magnesium. So what we want to know now is, what's the percent yield? Where's our theoretical yield? Are we given our theoretical yield here? No. This piece right here, this 328.9 grams of magnesium, what is that? That's our actual yield. That's what we actually produced. We don't have our theoretical yield, so we're going to have to calculate that. Is there any way to calculate how much magnesium we should be able to produce from 265 grams of aluminum? Of course there is! So let's do a factor label. So we've set up our factor label to figure out how many grams of magnesium we should be able to produce from that amount of aluminum. And who's got a raw number? Okay, so we figure we should be able to produce 358.1652, etc. Whoops. So, what's this number? So we said that this number is our actual, let's actually write that in purple. This is our actual yield. What's this number? That's our theoretic. Yeah, theoretical. So now we've got all the numbers we need to run a percent yield. Okay, so what do you get for a percent yield? Pardon? Yeah. 91.8, well, I'm getting 82981. I put that whole number in. You typically keep all your numbers till the very end. So when we sig fig this, we have 3 sig figs to work with, because this number comes from something that had 3 sig figs. So you have to look all the way back to everything you used to get that number. So with 3 sig figs, we have 91.8% yield, which is probably pretty average for a setting like a high school chemistry lab with, we don't have the fanciest industrial equipment, and you have less than 1 year of chemistry lab experience under your belts. So that would be a reasonable yield. Not impressive. Wouldn't make me go, wow, but I'd go, yeah, okay, that's fine. Okay, so let's try another example. Okay, so now we're asked if same amount of aluminum, we give you 265 grams of aluminum and you produce 512.7 grams of aluminum oxide. What's your percent yield? So again, this is your actual yield. You have to compute your theoretical yield. So let's start that process. I went ahead and popped my raw number up here. So I got 500.73, etc. grams of aluminum oxide. That is my theoretical. Anybody got any objections? Well, that seems like a problem, doesn't it? Can we do a percent yield if we got more than we were supposed to? Yeah, of course. If you remember early in the year when you guys were doing material recovery, you were separating out a mixture, physically separating it, and a few of you magically created matter. You performed alchemy and created mass out of nothing. That's what happened here. And so, maybe you didn't dry the product before you massed it. Maybe your product is actually, you didn't separate it well enough, and maybe there's actually some of the other product in your aluminum oxide. We don't know what you did, but you did something. And it happens, so let's go ahead and calculate the percent yield. Okay, so we've got our setup, and what do we get out of this? 102%. How many sig figs can we have? Just 3, so it stays at 102%. This is one case where having over 100% is not a good thing. So you can have over 100% yield, but it means you screwed up. You know, it means that there's a problem. You didn't separate something out, or you know, you didn't dry your product before you masked it. So it does happen, but it's an immediate red flag that there was a serious error. This is the kind of thing where if you got more than 100% yield on a lab, for me, you'd be writing me an explanation of what we think we did. We didn't dry our product, and somebody sneezed into our product, and you know, we dropped a dead bug in there. Okay, that would explain it. So that's the two sides of percent yield. Comfort level from 0 to 5. Notice that in both of these problems, I only gave you a mass for one of the reactants. So you automatically start with that reactant, you go through a factor label until you get to a theoretical yield of a product. No questions asked. What if I was to do something a little bit different? What do you notice immediately? There are 2 reactants given. Now, I borrowed this from your quiz on limiting an excess, so you already know that one of these is not going to react fully. Which one do you want to use to start your calculations to find your theoretical yield? You have to use your limiting. If you don't use your limiting, your theoretical will be wrong. Because remember, the limiting is the thing that limits how much product you can create. Okay? These are the hardest ones. These are the toughest of the percent yield types. So the like super simple, I could train a chimp to do these in 30 minutes is, here's your theoretical, here's your actual, go. And then the next level is, I give you a mass of one of your reactants and say, here's how much you made of your product, what's your percent? And you have to calculate your theoretical. These are tougher because the first thing you have to do is establish which of those reactants is your limiting, and then use that amount to do your calculations. Now, we already know the punchline here, right? Because you just took your quiz. This is the first one on your quiz. So we know that this is your limiting. If we didn't know that, we would do the 2 factor labels, compare them, figure out which is the limiting. In this case, we don't necessarily need to know how much of the excess is going to remain for this kind of problem. We just need to know which one's limiting, and then we proceed from there. So let's go ahead and, knowing that we already know that the magnesium oxide is the limit, let's get our theoretical yield. Okay, so starting with our limiting, we get a theoretical yield of 265.586 grams of aluminum oxide, etc., etc., etc. The decimals go on. So when we go to set up our percent yield, we're going to take our actual and our theoretical, divide and multiply by 100. Would we have gotten a very different answer for our theoretical had we used our excess reagent? Yeah, we would have gotten a hugely different answer. So I will toss a couple of those at you also for practice. Let's go ahead and work through the percent yield. Okay, so we get a 97.5% yield. That's pretty respectable. In a high school chem lab, that's excellent. Questions, comments, or concerns? Okay, you've got plenty of homework practice to do. And beyond that, I'll have a practice sheet, but I was going to print it first period, so I'll have it before the end of the day. How's that? And you can pick that up anytime. Okay, we'll do a FIP. I'll have the practice and the key up by the end of the day. I'll plan on doing a FIP tomorrow. It's a FIP, so okay.